Hello guys, thank you for watching this video lecture. In this lecture, I want to talk about Boxplot and its usage in statistics. We already learned that a boxplot is a graphical representation of data and it shows the distribution based on 5 key summary statistics: minimum, first quartile, median, third quartile, and maximum. So first, we will find the smallest data point excluding the outliers. Then we will find the median of lower half of data set, 25%. Then we go for the middle value of the data set, or the median one. Then we go for the median of upper half of data set, 75%. And then the largest data point excluding outlier. This box plot displays outliers, extreme values as individual points beyond the whiskers. This box plot is also known as box and whisker plot because they visually summarize data using a box and whiskers to represent the distribution. So the box represents the interquartile range. It means the middle 50% of data from the first quartile Q1 to the third quartile Q3. And the whiskers extend from the box to indicate the minimum and maximum values within a specified range, typically 1.5 times of IQR from Q1 to Q3. And in here, any outlier beyond this range are plotted as individual points. So the combination of the box, which captures central data, and whiskers, which show data spread, give the plot its descriptive name. So where do we use in statistics? To visualizing data distribution, because it provides a summary of data distribution, including its spread and central tendency. It simply identifies the outliers, clearly mark outliers beyond the whiskers. That's why it helps detect anomalies. We can use Boxplot to compare multiple data sets because it is useful for comparing distribution across different groups or categories. It helps us to understand variability, like the size of the box and whiskers can help us to analyze data distribution and variability. And also it is very useful for handling large data sets because it is effective for summarizing large data sets without displaying individual points. Let's start coding. So first, suppose we have a data. Okay, so first let's bring our data. You can use any data that you want. So this is our data. For creating box plot, we need to import Matplotlib.py plot and pyplot, and we will rename it as PLT. So once the library has been imported, then we go for plt.figure, and in here we say that fixed size is equal to, for example, 7 and 5. Then in here we say plt.boxplot, and we will send our data. So here you can see this is our box plot. So let's add some other things also. For example, we can add plt.title. We can say, for example, box plot. Then plt.ylabel, for example, values you can say. And also we can add grid, like plt grid, and here we say true. And also in here we can decide the line style. So line style equals to, for example, dashes, and also transparency of the line. We say, for example, alpha is equal to 0.7, right? So let's see what happens. Here should be something, and grid is not there. This S should be small. Still grid is not there. PLT grid through line style. This L should be small. Okay, so you can see here, you can see the grids also. This 0.7, for example, if I change to 0.9, you can see these lines are more dark. If I change it, for example, to 0.3, you can see lighter. Then let's see what is this box plot. This box plot, first of all, let's see what is the length of our data. So length of our data is what? 40. Okay, then what is the median of mean of our data? So import numpy as np, then np dot mean of data. We can go for what? Minimum value of our data. So np dot mean of our data is what? 1.6. You can see here 1.6. This is the mean of our data. Then what is max of our data? Maximum is 9. You can see here this is the maximum. Okay, so now let's find the quartiles. np dot percentile and data and 25, right? So the first quartile is 5.07. You can see here this is 5.07, and the upper quartile we can go for this one, 75 and 7.8. So you can see 7.8 is here. So you understand how this box plot works. If you want to change it to horizontally, you can change this one as vert is equal to false. So you can see this is horizontal. So this box plot visually represent the distribution of the data set that we have. And you can see here we have minimum. This is the left whisker, and this is called as the right whisker. Okay. Then this is the first quartile, Q1 here, Q3 here. So this box plot shows that most of our data is here. These are my data sets. So I have G, K, and P. So one sample here, K sample is here, and P sample is here. So I want to plot together. So I say fig and what? AX1 and AX2 equals to PLT subplots 1 and 2, and figure size is okay, this one, right? So these are two plots that I have. I want to plot both scalar and box plot. So to create the box plot, so I ax1 dot boxplot ax1 dot boxplot, then I get data dot values, and then I add labels is equal to data keys. What is data keys? Because it's like a dictionary. This is a dictionary, right? These are the keys and these are values. K is keys, these values. P is key, these are values, right? So let's see what happens. Okay, you can see here box plot has been generated. You can see here these two are somehow outliers. You can see here in this data 408 is outlier, okay, and also 359 is outlier. They are out of the box. So this is our box plot. Next, I want to go for the scalar plot. So for I, and I say group and values in enumerate data dot items, Then in here, I need to go for x is equal to np dot repeat I plus 1 and len of values plus np dot random dot normal 0.4 and length of the values that I have. Then ax2 scalar is equal to x values, and also I can add alpha here is equal to 0.7 and label is group. Okay, let's see how it works. You can see the data here. I will explain in this code what I did. For I group and values in enumerate data items, this returns key value pair of the dictionary data that we defined here. Then each group is a key and value is the corresponding list of numerical values that we have in this dictionary. Then this enumerate data items, this generate an index I for each group starting from 0. Okay. Then we have x is equal to np repeat I plus 1 and length of values. This is used to create an array where all elements are I plus 1. This means that all data points in the same group will have the same base x coordinates. Then we have np.randomNormal. This add a small Gaussian noise with the mean of 0 and a standard deviation of 0.04 to each x coordinates because we want to avoid overlap when multiple points have the same y values. Then we go for plotting. So in plotting here, we have x dot scalar. This plots the values on the y-axis against x, and then alpha is for the transparency, and label group is for assign a label to each group for use in legend. So you can see here this data. So if I want to overlap together to see better, so you can see the distribution. We have two outliers here. Most of the data are here, and these are for whiskers. You can see this whisker is very higher, right? You can see here, but this one is considered an outlier and the same. So we can also, put them together. So if we want to put them together, what we do here, so we can say just we change. Okay, just let me copy paste this code here, and in here I say I need one plot here, and in here just I will remove this one, and figure size is okay. Then I need to define the positions. Positions is equal to np a range 1 length of data plus 1. Okay. Then the box plot will be in ax dot box plot, and in here dot data dot values, and data dot values, I don't need this one. Data dot values, then labels equals to data dot keys, and patch artist is equal to true. Box props is equal to dictionary. Face color is equal to, for example, light blue. Okay, I will explain what happens here. So in here, we said positions is equal to np a range 1 length of data plus 1. So first we get the length of data here, how many data we have. Then we created an array of numbers from 1 to the length of data. This plus 1, we want to consider the last one. And then, so in here, for example, if we have 3 groups of data, the positions will be 1, 2, 3, because we have 3 kinds of data here, 3 samples, okay? Then we create a box plot. So data.values, these are the retrieves all the data values, or you can say a list of numerical data that we have in the dictionary. Then here we have data.keys. Data.keys retrieve all group means key, right? Like G, K, P that we have here. And then this ax.boxplot is we want to plot to visualize distribution of data for each group. And then here we have patch artist. This enable filing the box plot with colors. And this box props, this is fill the box plot with light blue color. Okay, that's all. So this is what we did here. Then also we need to go for the scatter plot. So let me remove this all. So for I and key and values in enumerate data items, and then we say start from 1. Then in here x.j, this is slide jitter to the x position is equal to np.random.normal, so I 0.05, and size is equal to length of our values that we have. Then here we say ax.scatter xj values, and you can say alpha is equal to 0.7, then alpha is equal to 0.7, then you can say color is equal to red, for example. And you can also decide label, for example, you can say data points if I equals 1, otherwise nothing. Okay, so let's see what we did here. AX is not defined because here we say AX1. Okay, we did it, right? So you can see the data along with the box plot both together. Now I want to change the shape and the color of this box plot. So first of all, let's remove the second one. So we can remove the second one here. We have only one. Then we will define some colors because we want to change the colors. Colors equal to just some colors that we can define based on the hexadecimal format. This is one color, this is another color, and this is another color. For example, this one. Okay. Now we say that box is equal to ax box plot data values, then label data keys. In here we add something not is equal to true, then patch artist is equal to true, vertical is to true, also we want vertical, right? Okay, let's see what happens. There seems to be one error in patch. Okay, let's remove this one for this time being. Okay, so you can see the shape has been changed. So in this code that you can see here, first we had some boxplot function that you know this is from Matplotlib. Then we have data values and data keys that we get from the dictionary that we have. In here, we have something new, not true. Not this is a not box plot, shows confidence interval around the median. So if the nodes of two boxes do not overlap, it suggests a significant difference between the median. Then we have patch artist. This enables color filling for this one that we have. So for example, let's change this one to false. So you can see this will be like this. Then if I change this one to false, then you can see it will be something like this, no color inside. And if I change this one to false, so I will both change both to true. Then for coloring, so what I do here, I say for patch and color in zip box, and in here I will call the boxes that I have and colors that I have. So then in here we say patch dot set, and also I say patch dot set alpha is 0.7. Okay, so you can see here the color of these box plots has been changed, right? So you can go for different kind of box plot with different colors. So this zip pairs each box object with some color. So this allows us to assign different colors to different boxes in a loop. Alright, in this lecture we learn about box plots and we try to plot different kind of box plots. We understood how they work and how they present the distribution of data. Please practice and feel free to ask me if you have any questions by sending me an email or by posting a comment below this video. Thank you.